Prestressed concrete in tower in building, mostly we see the thickness of slab is very less. The bridges, the girder of the bridges are made in the factory then transported on the site. The bridges have much more longer span. Also the concrete thickness is very short. High impact road nowadays are built. The concrete section wall or concrete panel are made in the factory then it's transported on the site. Nowadays these all things are common. We know the behavior of concrete. Concrete is weak in tension. When the tensile load is applied, concrete broke into pieces. So we put the reinforcement. For the shorter span, reinforcement is good. But for longer span, reinforcement can easily bear the tensile load, but the cracks still appear at the bottom of concrete. Due to cracks, reinforcement get the corrosion. So cracks and corrosion, structure may lose its strength and it may lead to the failure of whole structure. To avoid the failure of the structure, so we have a technique. This is called prestressed technique. What is prestress? When we produce a force within the structure, within the beam, by adding some tendons, some threaded bars, some strands, some bundle of wires. These wires are stretched by force, so it can produce a stress force within the structure, and this force can counter the applied load and it can prevent the deflection of the beam. This is called prestressed technique. Basic principle of prestressing. As we know, when the load is applied on the beam tends to deflect downward side. So to avoid this, we put the tendons. These tendons are stretched by force. So due to that, these tendons produce a stress force within the beam. It may cause the deflect to upward side. So the load is going to downward side and the by tendon is going to upward side. These both forces neutralize each another. Then we get a stable structure. Types of pre-stressing concrete. There is two methods, by post-tensioning and by pre-tensioning method. Basic concept of pre-stressing. By pre-stressing the structure, we produce a counter force within the structure which can easily handle the applied load. So there is no longer need to increase the depth of the structure. Also we can get the longer span of the bridge and the thickness is less. Pre-stressed structure is suitable for impact structure like runways and water retaining structure, dams and silos. No more corrosion and cracks, so durability is more higher and the structure is lighter in weight. So we can also get the different shapes. Pre-stressed structure is suitable for the nuclear testing site where the nuclear test is going on. These structures are also made of pre-stressed concrete because pre-stressed concrete is easily bear the impact forces. Some advantages of pre-stressed concrete. It's reduced material cost, longer lasting, economical. Disadvantages of pre-stressing. It need high degree of workmanship and quality control. Special alloy steel are more expensive than traditional steel. Expensive equipment is needed and there are complex safety requirements. Pre-stressed concrete needs skilled labor. To understand pre-stressed concrete, you must watch Behavior of Concrete video. Link is available in description. Thanks for watching this video.